The next set of problems, that's the second property that we really want to worry about, and that's function composition. If f and g are functions, if you take f composite g of x, what that does, that takes f, so they're closest to each other pairs together, and you would work from the inside of the parentheses out. So this is taking a function and embedding that in another. Totally different than the algebra of functions. And I'm going to start with number 42. Did I give you a page number? Page 244. Okay, good. We have a page number. Let's get this out of the way. This says, this is f of x, this is g of x. Find g composite f of 3. So kind of like you memorize, you pair those together, f of 3, and you find g of that. You're looking for a bunch of y values, nothing more. The first y value is saying, if x equals 3, what does y equal? Which y? This y. So if I go to this problem and say, what does y equal if x equals 3? Negative 2 times 3 squared, 5 times 3 plus 7. That is negative 9 plus 15 plus 7. That's, what is that? 6, 13? And now what is it saying? If x equals 13, find me this y. Well, wouldn't that be 4? I'm going to work underneath. Wouldn't that be 4 times 13 minus 3, which is 52 minus 3? 49. If I look at number 46, the same deal. This is f, this is a y, and this is a different y. Find me f composite g of negative 4. Again, you have to pair the closest together. You say, I want to find g of negative 4, and I'm going to take that and embed it in the function f. So if I want to find g of negative 4, I'll go not to f, to g, right there. And I figure out what y equal when x equal negative 4. That's really what that means. Wouldn't that be negative 4 over negative 4 plus 1? Isn't that negative 4 over negative 3? That is 4/3. So now what is it saying? This is saying take f function, find the y, but this y, and there's the equation. Wouldn't that mean that's going to be 8 minus 4/3 squared? Isn't that 8 minus 16 over 9? Wouldn't that be over 1? The common denominator is 9. 9 times 72 minus 16. And what's 72 minus 16? That is a 6. That is a 5. 56 over 9. And that would be my final answer. So this is the composition, embedding a function within another. Embedding a carb within an engine. Next level up, I want to do problem number 48. This is based on what we see. Again, don't let that throw you off. You compile those together, f of negative 2, and you take f of that. So when you start from the inside out. This is asking to find the y when x equal negative 2 in the f function. So if x equal negative 2, what does y equal? Well, f of negative 2 is actually a negative 2 squared plus 4 times negative 2. That would be a 4 minus 8. That would be a negative 4. So this value is a negative 4. Inside out, that's a negative. What is this saying? This says take x equal negative 4, go back to the same function and figure out what y equal. Now, what if x equal negative 4? What would y equal? Well, wouldn't you throw a negative 4 in there and there? Say that's negative 4 squared plus a 4 times negative 4. That is 16 minus 16. That happened to be 0. So this is having a function call itself. If you program, this is called overloading an operator. A very good application. It sounds bad, but it's good. Here, if I group those together, I'm finding g of negative 5, and I'm going to take g of that. So that's going to be g, and I work from the inside out. This is saying, go to g, there's g. If x equal negative 5, what does y equal? Well, g of negative 5 is going to be a negative 5 plus 2 over negative 5. That's going to be negative 3 over negative 5. That is 3/5. And if I know this is 3/5, this says, go back to g one more time. What's up, g? And throw in 3/5 right there. So again, another y value. They're all a bunch of y values. If I throw 3/5 in, what am I going to get? Well, that's going to be 3/5 plus 2 divided by 3/5. This is a complex fraction. LCD for the top and the bottom combined is a 5. Multiply this by 5. And that would make this a single fraction. You ignore the denominators. That will be 3 plus 10 divided by 3, which is 13/3. You could do this any other way you like. 54 is the next problem, and here they're asking for two things. F Composite G of x. I group those together, and I work from the inside of the parentheses out, meaning start from the inside. What does g of x equal? Notice here they didn't give us a value. They want the entire function. And what does it say now? It says go to the function f. There's f. Wherever you see an x, replace that mess in it. So that will be 5 minus 4. And in place of that x, I'm going to replace x squared minus 4. If I clean that up, distribute the negative 4. And that's going to be negative 4x squared plus 21. And if I run this backwards, that is, if I group those together, f of x, and take g of that, that would be g. And now I'm doing this, replace f of x by what it equals. Same thing, right? You'll be surprised how different those are. And that would be, go to the function g, right there. Wherever you see an x, replace that x by 5 minus 4x. If you FOIL, minus 2ab plus b squared minus 4. That would be 16x squared minus 40x plus 21. And as you see, F composite g of x is not g composite f of x. Not necessarily. They could be totally different. Right? So if you're cooking, if you're going to use oil and fries, it makes a big difference whether you put the oil first, heat it, then put the fries in it. Reversing that, putting the fries in first and heating that, and adding the oil on top doesn't work the same way to make French fries. So the ordering is extremely important. Another example for us is number 60. F composite g, we group those together, so we're taking g of x. Anytime they don't give us a value, that means they want to embed the entire function. What's g of x? The g of x is the square root of x minus 4. Go to the function f. There is f. Wherever you see an x, replace x by that radical. So I'm going to take a 2, replace the x by the radical squared plus 1. And wouldn't that cancel the radical? And if you distribute that in, that will be 2x minus 8 plus 1. That's 2x minus 7. And if I try to find this, again, I'm going to take f of x first and take g of that. That is g. And here we're trying to figure out or replace the entire f of x. F of x is really all of this. It's really 2x squared plus 1. And this is saying now, go to the g function. There's g. Wherever you see an x right there, throw the 2x minus plus 2x squared plus 1n, so the square root and a minus 4 are there. You're just going to replace that x by 2x squared plus 1, and if you clean this up, that's 2x squared minus 3. Again, nothing alike. Composite functions are used drastically these days, especially with the use of reusing programs over and over. The last problems are really fun problems. They're kind of for your enjoyment. I thought I'll throw in something, a bonus for you guys. And let me show you how that works. It's fairly simple, a lot easier than you think. So anytime I'm looking for f of 3, f of 4, f of 5, I'm looking for a y value. Here's a function f, here's a function g. This, according to the algebra of functions, f of 2 minus g of t. F of 2 minus g of 2. So what are we looking for? Y values. This says, use the red. F is right there, it's in red. G is in blue. When x equal 2, right there, that's x equal 2. What does y equal on the red? Isn't that a 2? How about the blue? If x equal 2, isn't that point? What does y equal? Isn't that a 1? 2 minus 1 is 1. Problem 1 done. Let's go for the next problem. On the next problem, I'm looking for f times g operating on 3. That's f of negative 3. F of 3 times negative 3 times g of negative 3. That's two y values multiplied. And if I fix x to be at negative 3, negative 1, negative 2, negative 3, right there. On the red, isn't that point negative 3, 0? On the blue, isn't that point negative 3, negative 3? So the y value, and 0 times negative 3 is 0. On 76, I'm looking for g of 2 divided by f of 2. Again, that's the ratio of 2, but let me erase this and reset. Now I'm looking at x equal 2. At x equal 2, we're back here again. This point is 2, 2, and this point is 2, negative 1. I want g. G is the blue. That's a negative 1. And I want f. F is the red. That's a 2. And that's my answer. And if I go for the last, can I do composition? Yeah, I could. I just have to do the right order. If you recall, those two group together, so you're finding f of 1, and you're taking g of that. That is g from the inside out. What is the y value when x equal 1? What is the y value? Well, if x equal 1, the y value is 2. And now, this is saying, if x equal 2, now you jump to 2, what is the y value but in the g? Well, what's that point right there? Isn't that point 2, 1? And there's your homework. And that concludes this section.